Day 8, L3 measurement and sig fig. This is the solution video for Day 8, Lesson 3, measurement and significant figures. This was assigned Thursday. It's officially due Monday, but those due dates are really not essential, so we'll talk about that in class. So what measurement and significant figures has to do with is how do you read measurements or take measurements in a chemistry lab, and then how many digits do you record your measurement to? It's not just random. You can't just record to any number of digits. There are rules about that. So how you take the measurement and how many digits you record, and then how you do calculations, that's measurement. How you do calculations with those measurements, with those numbers, is governed by the rule of significant figures, or sig fig. So let's go ahead. You saw the video, so let's go ahead and just do a few of these. I won't do all of these for you. So I'm just asking you how many significant figures are in each of these. So let's start with this one. So the only thing at issue are zeros. Anything that's not a zero is a significant figure. So the only question you have to ask is about zeros. So the rule is that any zeros that are leading, that come before the first non-zero digit, are never ever significant. Any zeros that come between two non-zero digits are always significant. So these are not significant, 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 significant. So there's three significant figures there. Okay, let's skip down to this one. 20,300. Now you have two non-zero digits and you have a zero between those, so that's 3. The only question about these two is, are they significant? Trailing zeros are significant if there's a decimal point somewhere in there. A comma is not a decimal point. It's just to make the number easier to read. So there is no decimal point. So depending on what book you read, if there's no decimal point, then you either say that these are not significant or that they're uncertain. You're not sure whether they were meant to be significant or not. In this class, just so you have a common, a standard rule to go by, we will say that they're not significant. So if they're significant, if you wanted to make those significant, but not add another zero after the decimal, because if you do that, it becomes a significant figure as well, you can just put a decimal there. It's not usual that you see that, but you could put a decimal there, and that would make the zero significant. But there is not a decimal there, so we're going to say that the zeros are not significant, these two are not, so that is 3 significant figures. Okay, and what other one will we do? Let's do this one. Okay, so you have leading zeros, 3 leading zeros. It's a leading zero, but it's not really. It's just put there out of for formatting. You always put a 0 if you don't have any other digit in front of the decimal. You always put a 0 there. So there's really 3 leading zeros here. So those are not significant. None of those are significant. Significant, significant, and 0 in between is significant. And since there is a decimal point, this 0 is also significant. So there are 4 significant figures there. Okay, I'll leave the rest of those for you to do on your own. All right, let's do some calculations down here. So compute the calculator answer. So go ahead and use a calculator on this. That's the idea. And then give the answer to the correct number of significant figures. So just go ahead on your calculator and do the first one, 0.0021 times 2.0108. And let me try that again on mine. Probably done by now. Okay, and this is what we get. I'll write out the full calculator answer. And as you can see on my calculator, I'm getting 1, 2, 3, 4, 5, 6, 7, 8 digits after the decimal place. You're never going to have any precision or significant figures to that precision. So as I told you in the video, you can maybe lop it off after about 4 and feel that you're not cutting out any significant figures at that point. You don't necessarily have to write all this down, but I did, so let's go ahead and do it. Okay, so the rule for significant figures with multiplication is the answer is limited to the number of significant figures in the one of these numbers that has the least number of significant figures. So this one has 2 significant figures, 2 and 1. All those leading zeros are not significant. This one actually has 5 significant figures. So the answer is limited to 2 significant figures. Okay, so remember, leading zeros are not significant, so that would be 0.0042, and then this 2 is going to be used to round that 2. Since this is less than 5, that's going to stay as a 2. It's not going to go up to a 3. So it's 4.2, and that is 2 significant figures right there. All right, let's do one more. Let's do this one. Okay, so 20,000. And that gives you this number. Okay. All right. So this has 1 significant figure because there's no decimal. This has 5 significant figures. So our answer is limited to 1 significant figure. That's this one right here. So you're going to use the 0 to round that. Since it's below 5, it's going to stay as a 2. It's not going to round up to a 3. So the answer is 20,000. And I know that seems a bit strange. You multiplied 20,000 by a number and you still ended up with 20,000. But that's just simply because you don't have enough precision to say that that's any more than 20,000, anything other than 20,000. There's just not enough precision involved in that number. Okay, so let's go ahead and do a couple of additions down here. So addition, the rules are different, as you know. So let's go ahead and do the first one. So you're going to have to line these up. And then you see you have 4 digits after the decimal place there. You only have this 1. So you're going to place a line right beside that 1. And you're going to extend it up and down like that. Now go ahead and do the addition. Okay. And you have 3.1. And this is going to round this digit. It's a 0, so it's going to round it back down to stay to 1. So the answer then is 3.1. Okay, let's do this one right here. Okay. 2 places after the decimal, 4 places. So you go to the 2 places and you draw that line right down there like that. Do the addition. Okay, so this 7, this is the number of significant figures right there. This 7 is going to round that 2 up to a 3. So the final answer for this one is going to be, let me write it up here, I'm going to need space for the problems down below, 245. Okay, and there it is. All right, next is a combination problem. So you have 3.29 times 4.020 plus 52.012 divided by 3.83. So PEMDAS says you're going to do this and this first simultaneously. You do them at the same time, so it doesn't matter which is first, in other words. Okay, so we're going to do 3 with the first one, 3.29 times 4.020, and that's going to give you this. Okay, now we're going to do this division. Multiplication and division are equal in terms of PEMDAS. Okay, and I'll leave it there because we're not going to go to any more significant figures than that. And you're going to add those two then. Now, first thing we want to make note of is how many significant figures. So this one is limited to 3, so I'm going to write a little 3 above that one. And this one is also limited to 3 because of that, so I'll write a little 3 above that one. Okay, so the multiplications are limiting us to 3 significant figures no matter what the addition does. So let's go ahead and add those numbers. Let's line them up. You don't round anything until the very end, unless, as I said, it's a very long number on your calculator, and then you can, you can take the liberty of doing that. Okay. And I should have put a 2 here actually. 580. Yeah, I just made a math mistake here, so let me correct that. I'm kind of in the habit, I've learned after many years of doing math, I try to check my work as I go along. So this should have been 580.2. And then, yes, could I keep going on my calculator? Yes, but here's the thing. I know I'm going to be limited to 3 significant figures. No point in doing that. So I'm just going to draw the line right here. They both go 4 places after the decimal. So we've got 10. Okay, and that's the answer we get from the addition. But as I said, you're limited to 3 places, so it's going to be the 16.8. The 0 is going to round the 8. Since it's below 5, that's going to round the 8 back to 8. So your answer here is going to be 16.8. All right, and I will leave the next one for you to do. Okay, finally we'll finish up with a problem dealing with logs. I gave you 2 of them. Let's do this one. So this has 3 significant figures, and the rule was, it's kind of a convoluted rule when I read it to you on the video, but it basically says however many significant figures there are here, 3, that's how many places after the decimal your answer is going to have. So you go on your calculator and you take the log of 32.1, close the parenthesis, looks like that, and you get a really big number. So it's 1.5. And I'm just going to stop there. So since we had 3 significant figures, we're going to have 3 places after the decimal. So that's 1, 2, 3. That 6 right there is going to be the last digit. The 5 is going to round that up to a 7. So your answer is going to be, okay, so 3 significant figures, 3 places after the decimal. All right, you can do the other one on your own. All right, let's move on to measurement. So it really all starts with measurement in the lab. You take your measurements and then you come up with, you read your measurements properly, write down the correct number of digits in your answer, and then you come out and you do your calculations using those to the correct number of significant figures. So let's talk about how measurements are taken. So in the first one, what we have is I've just taken what is an imaginary interval of 1 centimeter. So from 5 centimeters to 6 centimeters, I've expanded it out so you can see it clearly and with great resolution. And it says the interval from 5 to 6 centimeters represents 1 centimeter. The small lines are millimeters. They're 0.1 centimeters. Write the proper measures for each arrow below. And you can just place them on these lines right here. So let's do a couple of those. All right, so it's 5 centimeters. So I'm going to have my measure in centimeters. So I'm going to put a 5 there. All right, and it's not to 1 millimeter. It's not to 0.1. So it's still 0.0. But I'm allowed to estimate how far that is between 0 and 1. And I'm going to guess. You can make your own guess. Again, it is a guess. It's an estimate. We don't know for sure. There's no lines there to tell us for sure. I'm going to guess it's 7. The key here is that we're going to 2 places after the decimal. One that we're certain of, how many millimeters. We can see that it's in the 0 millimeter range. We know that. And then this one's a guess. How far into the 0 millimeter range is that? All right, let's do a different one. Let's do this one. Okay, so this is 5.1, 0.2, 0.3. So it's 5.3 for sure. And now we estimate how far that is. And it looks like it's exactly halfway to me, so I'm going to call it 5. Again, it's going to be a number between 0 and 9. So 5.35. And let's use units to measure. We should always put those in anytime. So 5.35 centimeters. Okay, one more. And then I'll leave the rest for you. How about this one? So it's 5.1234567. We're sure of that. And then we're going to guess. I'm going to guess that that's, I don't know, 3. It might be a 2.5, but you can't go that many decimal places. You can't guess that second one. You can say it's 5.72 or 5.73. You cannot say 5.25. That's too many digits of estimate. Then you're guessing, you're estimating 2 digits, not just 1. So I'm going to say it's a 2. And that's centimeters. Okay, so that's how you read a measurement like that. All right. Okay, which of the following are a possible measure on the scale above? So I'm not asking you about any of these arrows. I'm just saying which of these is an accurate way to express the number of digits, could possibly be a reading that you could make up there to the correct number of digits. So I just told you the rule up here. So which ones of those would be? Circle the ones that would be possible, that could be a possible reading up there. Just based on number of digits. That's really all I'm asking for. It has nothing to do with these arrows up here at all. Okay? So go ahead and circle the ones that would be possible readings that you could have made on that scale up there. All right, let's move on. I'll leave that to you, because if I give you one of them, then I'll give you all of them. So I'm going to leave that to you. Okay, now I gave you some cylinders, 5 cylinders and a burette. So each of the short lines on the cylinders represent 1 milliliter, ml. Give your best estimate of the level in each cylinder to the proper number of milliliters. Now, unlike the one in the video, which I'm going to give you an example of a burette, these numbers are going up from the bottom. So they start at 0 at the bottom and they move upward. That's because you're filling up the cylinder. So as you put more and more liquid in that cylinder, the volume goes up. Okay, so remember what the rule is. You read from the bottom of the meniscus. Okay, so we look at this one, and it looks like 80. This is 80, 81, 82. It looks pretty much right. It's not quite. I can't see the 83 line. So I'm going to say, I can barely see it through that meniscus, but it looks like the meniscus is down below it. So I can make one estimate digit. So it's going to be 80.2. And it's almost a 3, but not quite, in my opinion. Your opinion may be different than that, so I'm going to say 2.9. Okay, 1, 2, and then almost a 3, but not quite to 3 on that one. Okay, so that's 80.29. And again, right units of measure, I didn't leave myself any space there, so it's milliliters. All right, how about this one? So we've got 20 point something. There's 1, 2, 3, 4. Okay, and this is just an illustration here. It's not an actual cylinder, but it looks like they put it right at that line. And what they're trying to illustrate is it's not this point, it's not this point, it's this lowest point. It's the bottom of the meniscus. So that's 1, 2, 3, 4, and it looks like it's exactly on 4, so we're going to put a 0 there. Okay. Some of these are a little harder to read. I'm going to try this one. So here's 30, here's 40, so it's 30. This is the 30 line, the one that goes all the way around. 1, 2, 3, 4, 5, 6, 7, 8. But it looks like it's covering up 9. So I'm going to say 30. And I made a mistake back there. You probably all saw it. Let me go back and correct it. Okay, so it's 38. Point. Okay, and there's the 8, and there's the 9. I'm going to say that's down kind of enough below that line to call it 0.8, 38.8. So 30, 1, 2, 3, 4, 5, 6, 7, 8, 0.8, 38.8. And that, again, is milliliters. And this is milliliters, right? The units of measure. And don't make mistakes like me. So what you saw my mistake. Okay, it's 81.2, so this should have been not that first place after the decimal, it should have been 82 here. And the whole time you were screaming at the video. Okay, so there's 82, and then it's up there to that 9 there, so I'm going to say 82.9. All right, so I'll leave the rest of them for you. I'll just show you one that's a little different. So this is a cylinder also, as is the last one on the previous page. This one's a burette. Remember, this is what we saw in the video. This is a drip, drip, drip. So you're going to start with the liquid up at a high level, and it's going to drip, drip, drip. It's going to lower down. So it's going to 1, 2. So this is measuring how much you dripped out. So if you started at 1 and the level ended up at 2, then that means you dripped out 1 milliliter. Now on this one, these big lines are milliliters. The little lines are tenths of milliliters. That's because a burette is really narrow. It's really skinny. You can see how skinny this is compared to this. So on this, each of the little lines is a milliliter. On this distance is a milliliter on a burette, and these little lines are tenths of milliliters. And again, you'll use those when we get back into class. At the very least, I'll show you some videos this semester where I'm doing titration, and you can read the measurements. Okay, so it says each number on this burette represents 1 milliliter. That's each of those numbers, and the small lines represent 0.1. So I'll leave that for you to do, but just keep in mind that the measure is a little bit different on a burette. Okay, this one's an easy one, and it's a concept I didn't put in the video, so I thought I'd put it in the assignment here. It's called parallax. It's how you read a cylinder or a burette. And so parallax occurs when a piece of glassware is read from an angle so that the meniscus does not line up properly with the lines. So all I'm asking you is which student, boy or girl, is reading the cylinder from the correct angle and why. Anytime I ask you a question that's just a one-word answer type question, boy, girl, you should still give me a why. That's always implied. You got to get used to doing that for the AP. Always give an explanation. It doesn't have to be long, just a sentence or so, but explain why. Who's reading that one correctly and why. Okay, so I've given you 2 images of scales similar to what I did in the video. So I want you to just tell me what the reading is to the proper number of digits. I'll do one of them with you, you do the other one. Okay, so this one is 200. These are in grams. This is a triple beam balance. 60, and there, this is after the 3, so it's 263, and then it's 0.1234. It looks like it's almost on the 5 line, but I'm going to make it interesting and say I don't think it's quite there. I don't think it's quite on the 5 there, so I think it's only to 4. So 0.4. So that's the 4 is that little line right there, and then I get my estimate digit, and it's almost to the 5, but I'm saying it's not quite there, so I'm going to call it 49. This is the estimate digit right there. I'm guessing on that digit. Okay, you might think it looks all the way to 5, and then you would have put 50. Okay, so you're going to do the next one. Okay, so some of you may or may not have asked the question to yourself, why are leading zeros not significant? They seem significant. I mean, after all, isn't this number different than this number? Sure, it is. So why wouldn't those be significant? The reason I'm asking that question is because I asked that question when I was learning this. They seem significant to me. Those are two different numbers. If you don't have those zeros there, you got a totally different number. But I'm going to have you do a conversion, a very simple one, just like we did earlier in the previous lesson. I want you to convert 1 milliliter into liters. And there's your conversion. So you make your ratio, and you just do a single multiplication, and write down how many liters 1 milliliter is. And then I want you to answer the question that I had to answer for myself. Write a brief statement explaining why the leading zeros you have on the liter. So when you compute liters, you're going to have some leading zeros. Why the leading zeros on the liter measurement are not significant. Explain that. And the clue, the hint to that answer is, what's the purpose of significant figures? Why do we use them? Okay, it has to do with measurements, right? So why do we use significant figures? So I want you to explain why the leading zeros, when you convert from milliliters to liters, why those leading zeros are not considered significant. Okay, and we'll discuss that in class, but try to write it out. Always try to answer these on your own. And that's the end of this solutions video. So the next lesson is on the basic atom. It's just a lot of questions. I'm not going to give you solutions to those. You can get those straight out of the video, and I would expect you to be able to do that. All right, so we'll see you in class on Monday.